Welcome to the DIY Honda Garage channel. The diagnostic trouble codes P0203 and P0204 indicate a malfunction in the injector circuits for the third and fourth cylinders, respectively. These codes trigger when the engine's control module, or powertrain control module (PCM), detects an issue with the electrical circuits that control the fuel injectors. Each cylinder has a specific injector managed by the PCM, and when these circuits malfunction, the PCM triggers these codes to warn the driver of potential engine performance issues, including misfires, poor fuel economy, or difficulty starting. The injectors are located on the engine's intake manifold, and problems with their circuits can stem from faulty wiring, bad connections, or even issues within the injector itself. It is crucial to address these codes promptly to maintain optimal engine performance and avoid further complications. DTC P0203 and P0204 indicate that there is a malfunction in the injector circuits of the third and fourth cylinders. The injectors are crucial components in your Honda's fuel injection system. They are responsible for delivering fuel into the combustion chamber. They are typically located on the intake manifold, directly into the engine cylinders for efficient combustion. Communication between the injectors and the PCM is essential. If wires become damaged or connections loosen, these error codes will appear. The injector relay is also an important part of the system, as it controls power to the injectors and is crucial for their operation. If it fails, it can prevent the injectors from functioning, leading to these DTCs being registered. Always inspect the surrounding components, as they play a vital role in the overall health of the fuel injection system. Several factors could lead to the DTC P0203 and P0204 being triggered. A faulty injector relay is one possibility. If the relay fails, it won't provide power to the injectors, causing a failure in the circuit. Another common cause is an open circuit in the wiring, leading to the injectors, where a break or fault in the wire prevents signal or power from reaching the injector. Lastly, a shorted circuit can also occur, where the wiring could be improperly grounded or touching adjacent components, sending electrical signals in the wrong places. Each of these causes can lead to improper functioning of the injector, requiring thorough inspection and testing to isolate the fault. When dealing with DTC P0203 and P0204, the driver may experience several symptoms indicating underlying issues. A common symptom is the engine failing to start, particularly if multiple cylinders are affected, as the engine requires proper fuel delivery for combustion. Rough idling or stalling may also occur, as inadequate fuel can lead to misfires, causing erratic engine behavior. Additionally, drivers might notice poor fuel economy due to inefficient combustion resulting from malfunctioning injectors. Monitoring these symptoms closely can aid in diagnosing the underlying issue with the injector circuits and begin appropriate troubleshooting. The first step in troubleshooting DTC P0203 and P0204 begins with verifying the problem and preparing the vehicle for assessment. Start by turning the vehicle to the on mode without starting the engine. This enables the diagnostic tools to communicate with the vehicle's systems. Next, clear the DTC using the Honda Diagnostic System, HDS. This step ensures that you are starting with a clean slate to accurately assess if the errors reoccur. After clearing, turn the vehicle to off mode, then start the engine. If the engine does not start immediately, crank it for at least 20 seconds to allow the system to initiate. Finally, check for any pending or confirmed DTCs with the HDS. This will help identify if the codes appear again and determine if the issue is persistent or intermittent. In this step, You'll evaluate whether the engine started successfully after your initial checks. The results of this check are crucial. If the engine starts, you should proceed to step 9 in the troubleshooting process, which suggests further examination into the electrical systems connected to the injectors. However, if the engine does not start, this indicates that you need to delve deeper into potential causes of the no-start condition. This could involve inspecting the injector relay, wiring, or potentially the PCM to see if they contribute to the problem. This step helps systematize the troubleshooting process, narrowing down the possible causes and directing focus to the correct components based on the engine's response. The next step involves checking the injector relay, which is responsible for providing power to the injectors. Begin by turning the vehicle to off mode to ensure safety while working on electrical components. Once the ignition is off, carefully remove the injector relay from its socket. It's important to inspect the condition of the relay. If it shows signs of damage or wear, it may need replacement. After removal, test the injector relay using a multimeter. Ensure that it functions correctly and can provide the necessary voltage for the injectors to operate. If the relay is found to be faulty during this test, replace it and continue the troubleshooting process to confirm if this resolves the DTCs. This step focuses on testing the +B in J line to assess whether there are any issues within the wiring. Ensuring proper voltage at this point is critical for injector operation. Begin by ensuring the vehicle is in off-lock mode and disconnect the injector relay before proceeding. Next, measure the voltage between test points located on the injector relay socket. These test points involve the female terminals in the relay socket corresponding to +B in J lines. You should measure the voltage between these points and a solid body ground for an accurate reading. If battery voltage is present, it confirms that the +B in J wire is functioning correctly, allowing you to move on to step 6. However, if no voltage is detected, it indicates a possible wiring issue that needs to be addressed, leading you to step 5. In this step, you will check the condition of fuse number A12, which is part of the injector circuit. Fuses protect electrical components from overload or short circuits, so a blown fuse may indicate a deeper issue. Examine the fuse to see if it is intact. If the fuse is functional, it indicates that power is reaching the +B in J wire, and you will need to address an issue elsewhere in the circuit. If, however, the fuse is blown, it's necessary to address potential shorts or other issues in the wiring, since this could lead to recurring DTCs. Depending on your findings, you may need to repair any detected shorts and replace the fuse to ensure a complete and safe electrical circuit. Proceeding into this step, the focus shifts to testing specific wires associated with the injector relay. Begin with the vehicle in on mode. Once again, ensuring safety by confirming the injector relay is disconnected. Measure the voltage between designated test points on the injector relay socket that corresponds to the MRLY line. Just as before, you should measure the voltage against a solid ground reference. Confirming the presence of battery voltage at these points indicates that the wiring and relay component are functioning as intended. If battery voltage is present, it supports that the circuit is complete and in working order, guiding the troubleshooting to step 8. Absence of voltage would necessitate further investigation regarding the relay circuit. This step requires a focused examination on the MRLY line by verifying the integrity of the wire. Start by turning the vehicle off and disconnecting the PCM connector A to isolate circuits effectively. You'll then need to check for continuity between the specified test points on the injector relay socket and the corresponding pin on the disconnected PCM connector. Checking for continuity is crucial as it confirms the pathway for the electrical signal and ensures that there are no breaks within the wiring. If continuity is present, it indicates that the MRLY wire is functioning correctly, and you can proceed to check any related service information. Conversely, if there is no continuity, it suggests there may be an open in the wire that will need repairing before moving forward. At this point, we focus on checking the NJRLY outline to ensure it is functioning as expected. Following safety protocols, turn the vehicle to the off-lock mode and then jump terminals A and B on the injector relay socket with a jumper wire to simulate a circuit connection. This action will allow further investigation into the integrity of the voltage outputs. Disconnect the PCM connector A to isolate signals further and measure the voltage between specified test points. If battery voltage is present at the measured test points, it indicates that the NJRLY outwire is functioning correctly, and this confirms that signals are being sent as intended. If the voltage is absent, however, further inspection and repairs will be necessary to establish a fault-free circuit. In this step, you will be revisiting the DTCs identified previously to determine if the P0203 code has been established again. This confirmation is essential as it specifies whether the issues persist or have been resolved. If P0203 reappears, you will proceed to Step 10 to investigate more deeply into the injector circuits involved with the third cylinder. If it does not appear, that suggests the issue may have been resolved, or it could be an intermittent fault, requiring further inspection into wiring, connectors, or other associated components. This step helps to confirm whether any previous actions taken have had an effect on resolving the injector circuit malfunctions. After completing all necessary repairs based on prior troubleshooting steps, this is the verification stage. Begin by clearing the DTCs within the HDS to reset any learned values from the earlier diagnostic sessions. Once cleared, start the engine to ensure it operates smoothly without any check engine light indicators. Running the engine for a sufficient time period will allow you to establish if any DTCs reappear. Additionally, a test drive of the vehicle is essential to simulate operating conditions and ensure that all repaired issues have been rectified and that the vehicle functions properly in real-world driving scenarios. Taking these steps verifies that the repairs were successful and that the fuel injector circuits are working as they should. To prevent recurrence of issues like DTC P0203 and P0204, regular preventive maintenance is essential. Schedule inspections on wiring associated with the fuel injector circuit, checking for wear, frays, or potential damage that could occur over time due to exposure or vibration. Testing the injector relays periodically ensures that they are functioning correctly and can control the injectors as needed. Furthermore, maintaining clean and secure connections at the injector and ECU, electronic control unit, helps ensure that proper signals are transmitted without interruption. Keeping these components in good condition helps prevent future electrical failures that could lead to performance issues or engine malfunctions. In summary, understanding the causes for DTC P0203 and P0204 is crucial for effective troubleshooting and repair. These codes highlight significance in the fuel injector circuits, which are integral to engine performance. Following a structured approach during diagnostics helps isolate and address the issues systematically, ensuring a thorough repair process. Additionally, engaging in regular maintenance and inspections of relevant components can significantly reduce the chances of similar problems reoccurring in the future. Proactive steps will help maintain engine efficiency and overall vehicle reliability, ultimately leading to a better driving experience. Please like and subscribe to the channel. See you next time.